I've just modified this microwave oven transformer into a dangerous little device. 800 amps of electrical current is about to be really bad news for anything made of metal. Today I'm in the mood to melt some metal. This microwave oven transformer used to be a dangerously high voltage device, but I modified it so the voltage is extremely low, and it's the amps now that are insanely high. High enough that when the electrodes touch this screw, it melts into a little ball of steel. This time I've hooked it up to a machine screw for melting, and when it heats up, it changes color and the outer layer bursts into flames. If I hold the electrodes in constant contact, you can see molten metal flowing down the screw, and within seconds, it's completely gone. I just love the way these light up and flash, throwing off sparks as they melt. This bolt is longer, so it's taking more time to melt. You can see an array of color changes as the metal heats up to the point where it begins to glow a burning bright orange. Back on my workbench, you can see the input voltage to the primary coil is about 120 volts AC, which is typical mains power in my area. And with this modified secondary, you can see I've stepped the potential down to only 3 volts. The voltage is so low that I can actually touch the live wires with bare hands and not feel anything, even though the power being generated is enough to completely incinerate this wood screw on contact. This much power has the potential to kill you, so don't ever try this yourself. Now here's a 5/16 inch bolt I'm trying to melt, and it's building up so much heat that my 4-gauge electrode wires are smoking. As it's cooling, I'll try a little amateur blacksmithing while I have the chance, because this got so hot I just melted my melter. 4-gauge wires just aren't enough to handle the extreme current pumping through these wires. That's okay though, because the primary coil is still good, so I'll just rip off the secondary so I can use the rest of this in another project, like making a makeshift stick welder. Look for that in a future video. In the meantime, I still have this other mott that was salvaged from a microwave in a previous project, and after making the proper modifications, I've got a new metal melter sporting this thicker 2-gauge wire. To fire it up, I'll attach input wires to the primary coil, plug those into a power bar, and flip on the switch. You can see the low voltage sparks off the terminals, and I'm measuring their potential at just over 2 volts. Once again, for your entertainment, I'm holding the leads barehanded, and you can clearly see there's power to the system because of the electrical arcing. There's also a visible amount of current pumping through this screw. The thicker wire should be able to handle higher temperatures than the first, so I'm going to experiment on various items around the house, like this iron nail, and a drywall screw. How about some lead solder, or a zinc washer, and various other objects made of metal. One friend suggested I try melting a padlock, and that seemed like a fun idea. It's at full power, and the steel retaining clip is getting extremely hot, but the metal isn't melting. Something inside the casing just caught fire though, and although the retaining clip isn't melting, the lock is so hot that the clip just fell open, along with the rest of it. I'll try a couple of amateur spot welds on some stainless steel, and I'm impressed at how much effort it takes to get them to break. When experimenting with an aluminum can, the electrodes cut through the metal like butter, but this thicker aluminum disc won't glow at all. I'm not sure how hot it is, but when I drip water on it, the water is instantly boiled and vaporized. I did get this steel coin pretty hot, and if it'll do that, I'm wondering what it will do to steel wool. Amazingly, nothing happens unless the electrodes are so close they're almost touching. Aluminum foil isn't very exciting either, but I've managed to reduce this sheet down to a little blob of metal. I've got some neodymium magnets ready, but the voltage is too low to get through all 8. However, if I tap onto 2, it seems to be working really well. They're getting so hot they've gone totally incandescent, and apparently have just been liquefied. These are among the world's strongest magnets, but after exposure to temperatures over 300 degrees Celsius, they lose most of their magnetic properties. Here's a large steel nut that's harder to heat, but in the end it glows very nicely as well. This one's just got so hot that it's exploding liquid metal. As expected, I got no visible reactions from a 250 volt light bulb or this audio transformer, but I did have a lot of fun melting down the tines on this fork. This brings back memories of curling plastic forks over the fire as a kid. It's not very useful anymore, but it looks pretty neat. I'm applying a current to the underside of this knife and can visibly see the point of contact. The whole blade is glowing, and this is looking really cool. At this point, the blade is really easy to bend. For my last trick, I got a circuit board with some high temperature solder that my desoldering iron wouldn't melt, but hooking a couple of nails to the electrodes gives me the ability to instantly liquefy the solder on these contact points. Well, we cheated death again and destroyed a lot of metal doing it. If you like these videos, you can support me by becoming a subscriber and sharing with your friends. I appreciate your support. Thanks for watching.